regarding the Rio Grande Basin and its importance of tributaries. In particular, Pecos River and Goodenough Springs. Those are important tributaries for the Rio Grande Basin, for the Rio Grande River. We barely talk about them. We have not talked about those tributaries in the forum within our events, and we believe that it's time to start addressing and lowering our scale of analysis to the tributaries, especially because now the research is focusing on where the water is going to come from for the main stem of the Rio Grande. And in particular, because these tributaries are contemplated under the 1944 Water Treaty. Before I turn on to our moderator today, Raquel Neri, who is our coordinator of our events, I want to thank, of course, our sponsors, as always, Texas Water Resources Institute, Water Resources Research Center from the state of Arizona, the University of Texas at Austin, the North America Development Bank, TCEQ, and California Water Resources Institute. Thank you for your support and for keeping us alive during these hard times. That being said, thank you to all the audience that is here and interested in the research that we have to present. Please pay attention, because I know our colleagues that are going to present today, I know that information that will present today is going to be open eye for a lot of us. So, Raquel, it's all yours.
Thank you, Rosario. Welcome everyone to another episode of our Science Talks series. The title of today's talk is The Importance of Tributaries, Pecos River and Goodenough Springs. We have a great lineup of experts on the topic. We have Ramon Saiz, who is Monitoring and Information Coordinator at the Cache Creek Conservancy, Ronald Green, hydrologist and independent consultant, Mauricio Flores, hydrologist at the Southwest Research Institute. And I will be moderating this session as in my role of programs coordinator of the forum. Each speaker will present their work for around 10 minutes, and then we will have a Q&A session. So please don't forget to put all your questions and comments in the chat. Before we move on into the presentations, I want to introduce our speakers today. Ramon Saiz. Ramon is an environmental scientist specializing in hydrology, environmental flows, and water policy. His doctoral research examined resilient flow regimes in the Rio Grande and Pecos River, integrating functional flow metrics, resilience theory, and water governance frameworks. Ramon is currently the Monitoring and Information Coordinator and GIS Specialist at the Cache Creek Conservancy, a nonprofit organization dedicated to the restoration and preservation of the Cache Creek watershed in Northern California. Welcome, Ramon. Our next speaker will be Ronald Green. Ronald is a retired hydrologist, formerly with the Southwest Research Institute and the consulting firm Fishbeck, Thompson, Carr, and Hoover. He has specialized in groundwater hydrology and environmental geophysics with a focus on water resource assessment and karst hydrology. He has volunteered on the State Board of Trustees for the Nature Conservancy in Texas, acting as chair for its Conservation and Science Committee. He has also served as board chair for the Greater Edwards Aquifer Alliance. Welcome, Ron. And then we have Mauricio Flores. Mauricio is a hydrologist in the Earth Science section of the Space Science Division at Southwest Research Institute, where he works on projects focused on surface water and groundwater interactions, hydrochemistry, and numerical modeling, especially with respect to karstic and semi-arid and arid environments. Born in San Antonio, Texas, he earned his bachelor's degree in environmental science and geology from the University of Texas at Austin, and his master's in civil engineering from the University of Texas at San Antonio. Welcome, Mauricio. And as we always do, we want to remind you that you can always support water resilience by donating through this QR code to support the activities of the forum. without any further delay, I want to introduce Ramon with his talk titled Review of Water Availability and Basins with Water Sharing Agreements. Please, Ramon, if you can share your screen.
Thank you, Raquel. I'm gonna start sharing now. All right. Well, thank you everyone, and thank you for the invitation. I've been a fan of the this series for quite a long time now, and it's really good to be quote unquote in the other side of the screen presenting my research that I did with my former advisor Sam. And yeah, just gonna start. So these results come from a paper that it is currently under review, which the main goal is started on reassessing the water availability of the Pecos River Basin. So that is calculating how much water under natural conditions were available in the basin. So what I did is I reconstructed the regulated stream flow. You can see here in blue, like all the gaps that the records had. Like, so this is data from the gauge stations across the Pecos River Basin. And I used different methods to reconstruct this data, spanning from mass balance when things were running smoothly, and using a quantile percentile or QPPQ method, regression, temporal disaggregation. So different methods to try to reconstruct the stream flow under the regulated conditions, so under the current conditions of the basin, spanning from 1900 to 2010. Then the other part of this project was the estimation of the natural flow regime using a mass balance approach to remove the human influence. So that is like removing the reservoir storage, diversions, return flow, and put everything back into the river. And we can see in here these reference hydrographs in blue that represents the natural conditions. So the lower boundary of those shaded areas in here represents the 25, and the thick line represents the median value, and the upper boundary represents the 75 percentile of the records that I estimated for the natural flow regime. Now, the main objective of this research was to compare this estimation with historical assumptions made when the Pecos River Compact was signed and when the Treaty of 1944 was established. So I compared this estimation with Cravioto and Lowry and Oribe Alba. And the idea was to evaluate how the long-term human alteration had modified the river conditions in terms of uh, the Pecos River Compact and the Treaty of 1944. So what were one of the most important findings that I have is human activities are the primary driver for this flow reduction, especially agriculture, diversion, groundwater overdraft. So I don't attribute everything to climate change. Garza Diaz, a colleague and friend of mine, on his thesis dissertation, she identified like a breaking point around 1949. So that is prior the compact to the effect. So the human activities had an important uh, pressure on the river resilience. And for this analysis, I identified 4 periods. So before the treaty was signed, the drought of record, wet period, and the recent drought that we are facing right now. And I focus mostly on these three gauge stations. Artesia, just because it represents a baseline for the natural and regulated conditions. We can see there is not much alteration on this part of the basin. The other key gauge station, Red Bluff, because it represents like the first major infrastructure going to Texas. It's a key point to evaluate those deliveries. And lastly, the Auli right before it reaches to the RGB or the Rio Grande. So looking at the data, we start to see a significant reduction in the water availability compared to the natural flow regime. And I'm just here stating as an example, the drought of record, there is a 78% reduction compared regulated and natural water on these gauge station. So it is a fact that regulated flows become significantly flatter and lower than the natural conditions across all these gauge stations. And similar behavior occurs in the four periods that I analyzed in this paper. And well, I was curious about how my estimation from the natural flow and my reconstructed data compares to other data available in there. So I compared the regulated flow with the data that Gravioto and Lowry had on his report on the IBWC, and it was pretty similar. The results align very close with the regulated flow that Gravioto established, so that was like super cool. Uh, it's an R square of 0.95 compared the yearly values. And what about the natural flows? So I compared the natural flows from 1900 to 1944 with the values established by Oribe. So Oribe on his uh, technical report, he has the natural or natural flow for some of the tributaries that are used for the treaty of 1944. And if we look at the values, we have some discrepancies, which was expected under the conditions that this data was calculated. And if we look here on the table, we have a strong similarity with the Rio Conchos that I estimated and that Oribe presents in the data. Similarly with the Rio Salado, we don't see much of a difference. Even if we compare the total flow for these six Mexican tributaries, the difference is not as important. But if we look at the US side, the tributaries, they are pretty much under the same magnitude, but the discrepancy of the water availability is almost entirely attributed to the Pecos River. For all of the US tributaries combined, the difference is about 5 million cubic meters. So there was definitely overestimation of the water that comes from the Pecos River. And these results, we have compared the consistency against a broader natural flow reconstruction that we have done for the past couple of years. And the issue is that under the Treaty of 1944, all the Pecos flow is fully located to the US. And the treaty was negotiated under this overestimation on the base flow. So if the Pecos has historically contributed far less water than assumed, so comparing the 1300 from Oribe and the 7800 that I estimated, that's roughly 41% of overestimation. And this has directly consequences for downstream users. And that means like water for the downstream part of the basin relies more on the Mexican tributaries or on the Mexican side. So yeah, just to wrap up, I think we don't have much time left. So the water for the Pecos River was overestimated. And what is this research is doing? It is calling for just more periodic science-based reassessment of the transboundary water agreement, especially by updating naturalized flow reconstruction, updating depletions, evaporation coefficients, and including surface groundwater interactions. It aims to include a more adaptive water governance mechanism. And basically, I think like my goal with this research was that hydrology or hydrologic sciences and water law in basins that have international treaties to evolve together.
Okay, well, thank you. I think Ramon and the other comments uh, present a good reason why this work needs to be done. This project has been a long time in the making, a number of years. There have been previous attempts to look at some of the character of the Pecos. There have been a number of reasons why it couldn't or didn't go forward. If we can go to the next slide, please. And this is the reason it is going forward. Some of the past problems were mostly with acceptance by the community and the landowners, but over time they've realized that they're going to benefit from better understanding the Pecos and the influences on it, both natural and anthropogenic. So it's really a cast of dozens. The project has been funded by the Bureau of Reclamation. It's called a Water Smart project. It'll be going for 2 years. Next slide, please. And the intent is to just look at the that part of the Pecos, mostly most of the reach that's in Texas, to understand it, what's going on. And Ramon showed that there's quite a bit of difference between what they thought it was and what it is, but it's not a static system. It's dynamic for a whole number of reasons, and it's extremely important. So if we look at the water budget centered around Amistad Reservoir, you'll see that the Pecos, these numbers are in terms of acre feet per year, is an important contributor to the Rio Grande. And if you look at the input of three main sources, and that's the Devils, Goodenough, which we'll hear about shortly, and the Pecos, that's about a third of the water that's discharged from Amistad. So, this area is very important. Next slide, please. So our understanding of this system is not good. There hasn't been a lot of good study on this. Ramon showed that there are a handful of permanent monitoring points. He's looked at those to give a good view of what's going on, but really there isn't a good history of data on both flow and the quality of data coming through the system. And there's a really good book. It's called Bitter Waters by Patrick Dearden that gives a really good understanding of the river. And the river is naturally has a big source of salinity in it from where it goes through evaporate beds. So, some of the quality issues are naturally occurring, but then we have an awful lot of activity out there, mostly oil and gas, that has impacted the river also. So once again, we don't know a lot about what has happened in the past. So this project was put together in order to take a couple synoptic snapshots of flow and quality. So one of those sampling campaigns, was last month. And there was a team, 3 teams actually, of about 6 people, with participants from a lot of those folks that were on the second slide. They were in 3 teams, as I mentioned, along 3 different reaches, and their intent was to go in there and take concurrent flow measurements and water samples to look at quality. Now, the samples that were collected for quality were both in the river and in springs that discharged into the river where possible. So if we look back at what was known about this system, again, it wasn't much. At Southwest Research, we did a reconnaissance groundwater model back about 8-9 years ago, and I was involved in the conceptualization of this. We knew the water quality coming into this, the reach that was modeled had poor quality. At the time, I thought that the two big contributors of fresh water were from Live Oak and from Independence Creek that discharge into the river. We've learned an incredible amount about what's really going on. Live Oak has a lesser role than I anticipated, but there are a number of major springs that have not been well documented and recognized that are now. Next slide, please. And so here we look at the reach of the river that was studied during this this project. It goes from Imperial down to the confluence with the Rio Grande. So once again, the intent is to see how flows change along there to find out where the river gains and loses, and to see how the chemistry changes throughout. There have been thoughts that, even though the river has some naturally occurring salinity sources along its reach, that some of the reasons that it is saline may be due to oil and gas activities, and it's important to understand that. So by sampling the chemistry along the reach of study and looking at the constituents of what makes up the salinity, we hope to have a better understanding of what's going on. Once again, those samples were only recently collected, so this the data from this field campaign, they are not yet available. But it's going to provide a basis to understand what's going on and maybe better answer those questions that Ramon posed in his presentation. Next slide, please. So this just shows very simply what we intended to do. We prior to the campaign, the team helped identify where to sample the river, where some of the springs were, where there was access. And once again, the team did an outstanding job of gaining access from landowners, something that was not previously possible. And so at each location, the idea was to measure the flow in a gain loss survey, collect water samples, and then once we get all this information, we'll be able to understand the dynamics of the river. There'll be another sampling later this year, so we have two synoptic snapshots of what's going in, and we'll have a much better idea about what the river budget is and how it changes over its reach. Next slide, please. So here you can see a summary of data that's available. There are a number of wells. You can see the density changes with areas. As time goes on, once we get this basic understanding of what's going on with the river, we hope to expand this into additional springs once we see, where there may be reaches that we did not clearly identify springs discharging into the river, and the impact of wells. And those would be both wells pumping water out. And as we know, there are an awful lot of wells out in this area as part of the Permian and the upper reaches in particular, where there is produced water of high salinity being discharged into the subsurface that may be impacting the recharge to the river. Next slide, please. So here are some photographs of the effort. And again, I want to recognize all the teams that the folks that were involved in this. Again, they're on that second slide, but it was an amazing effort. There were close to 20 people working on this campaign, and only 2 were funded by the actual project. So that really stretches the research dollars on this project to get that many people out over a very short period of time, so we get a very clean and clear synoptic view of what's going on. So there are samples out for analysis as we speak, and this will be brought back to the permanent forum in the future to give them a better idea what's going on. So next slide, please. So a number of tools, analytical tools, will be used to understand the waters. Chemistry will be looked at to give basic chemical fingerprints. But as far as the well water goes, there were also an expanded suite of analytes that were tested in order to better understand the groundwater. It didn't make a lot of sense of sampling the river water for that expanded suite of analytes, just because it wouldn't have been very meaningful, and it's quite costly. Each sample for the wells is somewhere around $2,500. So by having all these people help with the field work, it really allowed the project team to devote those resources, those financial resources, to collecting additional samples and just getting a better look at what's going on. Next slide, please. So the whole idea is to understand the water budget throughout this reach, and to put it in context of how it's going to impact the Rio Grande, which is one of the prime motivations and justifications for this study. And over time, hopefully this effort will be built upon. Next slide, please. So here we see the budget, the water budget, sort of illustrated, and you can click through the next few buttons. There you go. A couple more, all the way down to there you go. Oh, okay, thank you. So you can see that this is a complicated system. It was shown a little bit in Ramon's, where his river got fat and got skinny. You're up in New Mexico and around Carlsbad, and the river is very large and the quality is pretty good. Then you get down around Imperial at the upper end of this reach that was studied, and there are places you can step across the river because the flow is so small. And then it gets much larger by the time you get down to the confluence with the Rio Grande. So by having all these transects of gain-loss measurements, the different losing and gaining reaches will be better understood pretty much for the first time, and the quality of water that's coming in or discharging will be better understood by sampling the waters for their and testing for their chemistries. So down at the bottom left, you see that we're going to be looking at the water budget in terms both of quantity and quality, which will be very telling as we go forward. Next slide. So this just shows some of the density of the sampling, and if you compare it to where the permanent measuring points are shown by Ramon, and on an earlier slide here, you'll see that the density of data is considerably greater, and in the past these data just were not available. So we have the Forgotten Reach, which was the upper half, and the lower reach, and the team did as best they could to get access. Gaps in the coverage will be identified once we get through the chemistry and the gain loss results, and we'll try to fill those in the next sampling and in future efforts. Next slide, please. So this shows altogether the effort that was put forth, and once again there were 3 teams of 6 people each, and they just did a tremendous job. Logistics was an incredibly complex undertaking, and Julie Louie with the Nature Conservancy, even though she was on maternity leave, did an incredible job of getting everything lined up. Plus, there were landowners and other NGO and governmental agencies that assisted. Next, please.
1 more minute, Ron. That's okay.
Okay, well, this is it.
Thank you.
So it's going to be, this just gives the sort of the relevance of the study, and, you know, going back to the discussion of the Treaty of 44, you know, it's both the quantity and the quality of the Pecos that are important. We don't understand what's going on between the natural and the anthropogenic impacts. This study will get us there. So with that, I'll tie it up. Thank you.
Thank you, Ron. Our third speaker is Mauricio Flores, presenting Investigating the Springs of the Amistad region. So Mauricio, if you can share your screen, please.
All right, great. So thank you, everybody. As Raquel mentioned, the title of my talk is Investigating the Springs of the Amistad Reservoir. But before I get into it, I want to further highlight the importance of the relevance and the importance of all the different entities that have supported this work and all the other work that we have done in the region. It wouldn't be possible without the funding from the Koipu Foundation, the Border 2020 and 2025 program from the EPA administered by the NAD Bank, and without the important support of the IBWC and SELA, both sections, National Park Service, etc., lots of community groups, and of course all the landowners in both the U.S. and Mexico that have granted access to their lands for accessing wells and other sites for sampling. So it's really a big effort across the board to get these kinds of projects off the ground. And so for some background, it's pretty well known that the water resources in the Amistad region are critical for local and downstream communities. So right here, I have a diagram showing the basic water budget diagram of the Amistad Reservoir region. Ron had it in his presentation as well. So I have the units in acre feet per year, and then in smaller text under the smaller numbers are in cubic meters per second. And it just kind of highlights the importance of the different tributaries, as Ramon and Ron mentioned, the Pecos River being a key one. And then also there's the importance of springs such as Goodenough Spring. Despite this importance, though, there are still a lot of uncertainties regarding the water resources of the Amistad region as a whole. For example, what are the source areas of springs and the relationships between the different springs, and what are those implications for surface water, groundwater interactions in the area? How connected are the transboundary aquifers in the region? Here I have a figure of showing kind of the extent of the transboundary units in the area, such as the Edwards Aquifer, that based on some of the work that Dr. Sanchez has done in the past. And it's just, but there's very poor understanding about how connected, how interrelated both countries' portions of these aquifers are. And then, of course, how will the climate change and land use change impact specific areas? That's a big issue across the entire Rio Grande Basin and across the world generally. So studying the springs in Amistad region, we have focused primarily on Goodenough Spring and San Felipe Springs in the area. Goodenough Spring used to be the third largest spring in Texas prior to the construction of the Amistad Dam. Once the Amistad Dam was constructed, once the Amistad Reservoir was constructed, it became submerged under Amistad, under the lake surface, and now it kind of varies, but depending on the lake levels, it varies from 100 to 150 feet below the lake surface, and as I'll go into later, flow has been affected as well by that construction of the dam. But one of the key questions for Goodenough Spring and all the springs in the area has been, what is the source area? What do we know? What can we figure out about the source areas? Because the more that you know about the source areas, and the better you can protect or safeguard or manage the water resources that are issuing from that spring, the portion of the water budget that is coming from that spring. And for Goodenough Spring, it's particularly interesting because it's in the Treaty of 1944, as we see in this text right here, all the waters reaching the main channel of the Rio Grande, Rio Bravo, from Pecos and Doubles Rivers, Goodenough Spring, and Alamito, Terlingua, San Felipe, and Pinto Creeks are allotted to the United States. And then there's another segment going into which which tributaries are allotted to Mexico. So this is a case where, okay, the spring outlet is officially in the United States, but where's the source area? Is it binational? Is it more in one country or the other, etc.? And what kind of implication does that have for water management? And how does that affect our understanding of the system as a whole? And as far as Goodenough Spring goes, anecdotal evidence has indicated in the past, well, it seems that this spring, prior to the construction of the dam, would react more to storm events that occurred exclusively in Mexico, or primarily recharge events that occurred in the Mexico side. So then that made some people believe, okay, maybe it's actually coming from Mexico. Maybe even though it's the outlet itself is in the United States, possibly the flow is coming in. It's mostly contributed by parts of Mexico, and so there wasn't a lot of research going into, okay, what can we do to figure out, the extent of this possibility, etc. And for San Felipe Springs, it's the main water source for the city of Del Rio, a very important spring. And one of the main issues there, like many springs across the state of Texas and in arid environments, is that the creek and the springs are increasingly vulnerable to drought. And further, again, investigating the source areas for that can help understand how well you can what you can do to help manage those water resources. And aside from these two main springs that we've looked at, we've also sampled uh, various springs in Mexico that are along the Rio Grande, such as Lourdes, Carmina, and Brotante. And then we also have, of course, many other springs in the Texas side, such as August, Big Satan, Dolan, Indian, and Cantu. And so it's a very spring-rich region, and springs are a very important part for understanding surface water and groundwater interactions in the area. And so here I have a few photos. The photo on the left is a photo of what Goodenough Spring looked like prior to construction of the Amistad Dam in 1969. And then the middle photo is a picture of what the lake looks like. That buoy kind of marks. It's not the exact Goodenough buoy, but it's close. It's looking. It's about approximately where the Goodenough Spring would be under now in the lake level, so submerged 100 to 150 feet below the lake surface. And then we have San Felipe Creek in the other photo. And so, like most of our research so far has consisted, let's collect water samples from wells, from springs, occasionally from surface water, get those samples analyzed at labs for major ions, isotopes, etc., a comprehensive geochemical suite. And so here we just have a few photos from our fieldwork, sampling the different springs and wells in the area. We have the photos of the divers over here getting ready to dive down to Goodenough Spring because it's a cave, a spring issuing from a cave, and it's underwater, 100 to 150 feet. It does require specialized cave diving techniques to get samples from. And then we also got help from divers sampling San Felipe Spring as well. And so over the years, we've sampled. This is a map of all the sites that we've sampled over the years through these projects focused on the Amistad region. And so we have several springs. We can see several springs along the Devil's River, San Felipe, Cantu, and then the Rio Grande springs that are on the Mexican side, and then several wells in areas in the ranches farther west in the Acuna municipality. And so the key thing that we focused on so far has been preliminary analyses of geochemistry, of the hydrochemistry, because these constituents, when you look at the geochemistry, you can kind of assuage, you can look at different nuances that are basically serving as chemical fingerprints of the different waters. So different chemical constituents can kind of give you clues about, hey, this is how the water evolved from point A to point B. These are the different environmental things that might be happening along that water's flow paths. This water may be recharging in this kind of environment or that kind of environment, etc. So combining a comprehensive set of geochemical parameters such as ions, isotopes, etc., can help you construct a more comprehensive picture of what is going on, where are the waters, what are the source areas, what is their history, etc., and potentially identify additional gaps as well. So here we just have a Piper diagram. It's just basically a summary of the major ion chemistry of the waters that we have sampled, along with some samples from just historical data from TWDB databases, etc. And generally, the major ion chemistry just confirms what's been well known over for a long time, is the springs and wells in the area are generally characterized by calcium magnesium bicarbonate composition. That's the most common composition in the region. Although most of the springs that we sampled in the Mexico area do show a bit more of a mixed composition. So there are variations here, and that's kind of like a first look. The major ions kind of provide a first look at what the general composition is. And then we also looked at different isotopes. We looked at deuterium, oxygen 18, we looked at carbon 14, strontium, etc. I'll just go over a few in this talk, but basically the different isotopes can help you get an idea about, help you investigate different environmental processes that may be a part of the history of that water. So for example, deuterium and oxygen 18 are very helpful in understanding precipitation and evaporation regimes, or precipitation and evaporation dynamics and their impacts on the water chemistry. And they can also be used as a proxy for what the relative elevations at the different waters recharged at. So for example, depleted very low values indicate probably relatively high elevations, like in the mountains. And then enriched or larger values can indicate probably more local or in valley or origin recharge areas. And so for this area, for this particular study, including all the Mexican wells and the Goodenough Springs, San Felipe Springs, and all the other springs, the deuterium and oxygen 18 values suggest that Goodenough spring waters recharge at relatively higher elevations compared to other springs in the area. And this is true for some of the wells in the El Caballo watershed and La Zorra watersheds in Mexico as well. Whereas San Felipe Springs and most of the Devil's River Springs and other springs in Texas side have more intermediate elevation. They're more along the intermediate area. And then Lourdes, Carmina, and Brotante, which are the three of the Mexican springs, along with Cantu Spring, which is a spring close to, also located in Del Rio. Those indicate that those might have the most localized recharge areas, at least as far as their main um, recharge area contributions go. And so, so this is one clue that indicates, hey, maybe, so it kind of helps us get an idea of in this way, these springs have probably different histories in terms of where the water that is coming out of them originally recharged. We look at carbon 13, carbon 14 isotopes. These can kind of give you clues about its interaction with the different types of soils and different types of the flow path, residence times, etc. Can be a proxy, and we use this to also kind of help arrive at approximate radiocarbon ages or groundwater age dating as well. But here I have a plot just showing the relationship between carbon 14 and delta carbon 13. And this is just kind of giving you an idea as the farther along the farther down along the y-axis and farther along the x-axis, that indicates probably older waters, or at least waters that have a much longer flow path as those go down. So generally speaking, the Devil's River watershed springs and the San Felipe springs seem to have relatively shorter flow paths, probably more localized flow paths. Whereas Goodenough, Maris, one of the Mexican springs, and Deadman's Canyon in the Pecos may have longer flow paths or have longer residence times before that water reaches and gets discharged at the point where they get collected. And then Lourdes, Carmina, and Brotante are a little unique. They don't quite follow either of the trends that most of the other springs do. They have high percent modern carbon, but intermediate delta carbon 13. And that's just kind of an indicator that, hey, when we're looking at this particular isotope, there's these particular isotopes rather, you have potentially three different stories that you need to parse out and investigate further. And then there's also an example of strontium 87, strontium 86 strontium ratios. These can basically give you clues about what rocks or formations or soils the water interacts with along its flow path or where it's sourced from. So in this area, we don't have a lot of constraints on the types of waters, different strontium ranges for different rock formations and different aquifers. But what we do have, so far the suggestions are that Goodenough and Maris waters are pretty consistent with the known Edwards carbonate rocks ranges. So they're very characteristic Edwards aquifer waters. They come into contact a lot with the carbonate rocks that are characteristic of the Edwards aquifer. You have San Felipe and most other springs having varying degrees. They're along the middle area, right here between the two rectangles. That indicates that could indicate that they have interactions both in terms of with the Edwards rocks and some significant uh, interactions with the surface soils, etc. And then, but as I mentioned, we still need further constraints on these values in the region to kind of have a better handle on this particular aspect. But overall, when we're trying to bring together the major ion chemistry, the isotope geochemistry, etc., we and the preliminary picture is that the major ions kind of tell us there's potential mixing of waters of the groundwaters underlying watersheds in both of the countries. There's a potential binational or international component contributing to the spring flow overall. And some of the isotopes indicate, especially the deuterium and oxygen 18, indicate that there's probably a very strong or even main component located in Mexico based on those signatures of high elevation uh, recharge that are most likely originating from these the purple and red high elevation areas that I have indicated on this map. Uh, those are some preliminary delineations for the Goodenough Spring source area components. And this is very likely to change and get further refined as further water quality sample collection is conducted, additional geochemical modeling, etc., and further research continues. For San Felipe Springs, we also found, the major ions just show us, there's a lot of similarities with other Edwards waters in the Devil's River, in the Devil's River and San Felipe Creek watershed, of course. Whereas the isotopes kind of show a range of, there's probably different contributions of waters coming from as far away as the northern reaches of the Devil's River to waters that are also more contributions that are more localized as well. And of course, there's also the impact of the Amistad Reservoir that may have impacted the flow at the San Felipe Spring as well. So in general, the binational implications, I think, are just pretty much, the complexity revealed by the chemistry highlights the importance of needing to address groundwater in conversations about for future binational water management, binational water research, etc. And because as we see, although spring outlets are in either one country or another, those are the point locations where the water is discharged from. The source areas may be more complicated. It might be both countries, one country or the other, etc. And that needs to be more fully understood. Springs are very important canneries in the coal mine, so to speak. If they're basically they're the surface expression of what's going on underground. And so if you see, springs going dry or springs going dry more often, as is often the case in Texas and in other arid regions, then that's an indication that there's something out of balance in the system. And of course, these springs, because they're out surface expressions of the groundwater, they can help contribute to our better understanding of the story of what's going on at the surface water and groundwater connection. And then, of course, groundwater and surface water are intricately connected. And here I just have some figures maps showing the extent of, the importance of the different tributaries in the region. We have the Pecos, Devils, etc., El Caballo, Nazora in Mexico, Las Vacas, and many others. And then, of course, the extent of the transboundary nature of the aquifer is also based on Dr. Sanchez's recent research. And so with that, I am done. Thank you.
Thank you, Mauricio. We have a couple of minutes to start the Q&A session. So I'm gonna ask Sam and Rosario to chime in and help me moderate this session. Also, if you, between the speakers, want to have some exchange of ideas, everything is welcome. So please feel free.
Mm-hmm. And I thank you, everyone. Ramon, Mauricio, Ron. I think, Ron, I was doing exactly offline what you were doing during Ramon's presentation. I was checking numbers. Super spot on Mauricio's. It was 109, 103,000 acre feet per year from Goodenough, and I was converting to million cubic meters, 123, exactly what Ramon said. So numbers add up. That's always good. I don't know, perhaps. So actually, I would like to follow what Raquel is mentioning. Is there any comment that you want to do before actually I put to Ramon some of the questions, I have here questions for Ron. But before actually going to that part, any extra comment, something that you want to add?
I think we should go straight to the questions of the audience because we
Okay,
do
so
have
let's.
interesting questions.
Oh yeah, let's go there. So from Raul Morales is the overestimation. So these are three from Ramon, and Ramon, you feel free to respond which one you want. Eh, Ramón Morales, la subestimación es debido a la variación climática. The overestimation is due to the climatic variability. And then the next question, the slide reference implications for the treaty, 1944 treaty. What are those implications? If the Pecos River is allocated 100% to the US, meaning US don't have to deliver water to Mexico, will there be any implication for Mexico or on the treaty obligations? And the last one from Christy Muse. Most, if not all, releases from Red Bluff are to irrigation canals. There were no deliveries at all in 2024 and 2025. To my knowledge, there are no in-stream flow releases from Red Bluff. I will have to confirm. So that was a comment. Ramon, any on the previous two questions, any response?
Yeah, for Raul, is overestimation due to climate variability? No, or at least not primarily. I think the overestimation uh, it was due to methodological limitations, and as you saw with Ron's presentation, to the complete data available in the time that the 1944 treaty negotiation took place. And I think the clear evidence is that if we compare my estimates with the ones that Oribe did for other tributaries on both sides, the differences are minimal. For the Mexican tributaries were like 18 million cubic meters. So the one that highlights the most is the Pecos River alone, which points out to a problem of how the specific river was estimated in the 1940s. So saying that, yeah, climate does play an important decline on water availability. We're seeing more often these prolonged droughts that combined with these shifts in precipitation have declined the regulated flows. But yeah, sure, where I adjudicate this to the methodologies used and the limited data available. Shall I address the other question about the what is it? The last slide refers implication, what are the implications on a binational level? Oh, so this is one of those questions that makes it super interesting and complex. Uh, so the Pecos under the Treaty of 1934, 100% is allocated to the United States, but that doesn't mean that it doesn't affect Mexico. I just want to make an emphasis that this study does not make a legal determination. It just raises an important technical flag. So the treaty is a system. It's not a set of isolated accounts. It governs how water is shared between Mexico and the United States. So having an overestimation of water that was allocated to 100% to the United States, Mexico still has to deliver the 350,000 acre feet per on average for the length of the treaty on the 5-year cycle. So the negotiations included this assumption that the U.S. contributions were higher than expected. And in fact, they were like about 40% less water than assumed during this negotiation. And I think the key trade implications are uh, accounting for these changes in this natural variability. And it is concerning at the end when they do the contribution mix at the Amistad Reservoir, if the Pecos flows were chronically lower than expected, the total volume of shared water that reached there is reduced, which just tightens the overall water balance of the basin. And yeah, for the comment from the releases from Red Bluff, yeah, Red Bluff is operational canal. I think it never included environmental flows or interflow releases when it was completed.
And just to add, so I think the main implications of the Pecos being overcalculated is that so that water downstream was consider for water availability in the lower Rio Grande. So when they were thinking about how much water will get to the lower Rio Grande on the US side, that one, that amount was considered basically as it was. So the size and the amount that was thought to be delivered there is not there. And I think it was overestimated. Let's go with bronze. Seeing here some of a
Um,
question for Ron.
some and Ramon, just to complement that, and this is just a
Mm.
question out of the so because we have an overestimation and therefore we have an over expectation of the flow of the river. So when we are dealing with current conditions and we have Mexico having trouble delivering, and also you were supposed to be expecting some amount coming from your own tributaries, meaning in this case Texas. So none of the systems are working. So I guess the implications that I see is that it makes the the panorama worst. The pain is bigger, and the
Mhm.
blame to Mexico's side might be bigger too. So for me, it turns into a political and social component, not necessarily on the accounting of the water, but it makes the problem worse for Mexico because that expectation still is there. I mean, most of this information is not known between irrigators or cities on the lower Rio Grande. So we see less water coming, and the immediate response is to blame the deficit on the Mexico side, which is real, but it might be over what is it? Over it might be overblamed about the water
Overrated. Yeah.
scarcity, overblame the scarcity in the region. So I just wanted to share that if this is correct, or this might be an implication, not necessarily legal implication, but it does affect the sense
Mhm.
of the urgency and the scarcity in the region. So I just wanted to point that out.
Yeah, and Maria Elena Giner says that the 1944 treaty was negotiated based on 50% share resources overall.
Can I
So if
comment
the
on that? Can I comment on that, Samuel?
yes, go ahead.
So what the bigger implication that I see more than what you're saying um, is that when the whole overall basin was looked at, it was envisioned that 50% would come from each country. So if the Pecos was overestimated and it had been estimated correctly, then in theory, the one third share may have been a larger share that the United States would have had to that Mexico would have had to contribute, right? So in essence, Mexico kind of won out on that, overestimation, and otherwise they would have had to give a larger share. Now the reduction in flow that's coming to the reduction in flow that's coming to the region after the 1970s has really decreased. And I think that's really more the pain point for Mexico, for the United States. Their tributaries have decreased by 35% as compared to the 1970s because of there's no known factor, right? That includes the tributaries and unmeasured flows. And IBWC at that time, when I was IBWC commissioner, really put forth all of that data to demonstrate that. And that are the pain points for the South Texas.
Okay, Maria Elena, good to know. Thanks for that one. I think we need to get to Ron's. I'll get back to your comment on the chat because Ron's and Mauricio's, I think this is super interesting. So surface water is coming and it's not what it's supposed to. And then the groundwater and the aquifers and the springs, they are saving us big time, my friends. Like super big time above Amistad. Like really, right now we're living pretty much on groundwater and springs. Ron, there are two questions for you there, and also one from Mauricio. So, from Gilbert Anaya, there is a spring flow from the Pecos that reaches the confluence with the Rio Grande. I think that one is a comment. Raul Morales, with the existence of a great amount of wells, are there any connection between surface water and groundwater in the Pecos?
Absolutely. Um, a lot of the reach that we were investigating was karstic limestone. And some of the previous work that we've done on the Devils in particular uh, better characterize the relationship of the subsurface with the surface. And because it's karstic, over time it's developed this preferential flow in, and improved or increased permeability uh, aligned with the river channels. So if you have wells that are close to the river, they're absolutely going to impact what's in the river. So, you know, just looking at a lot of the activities out there, it's mostly oil and gas, or there wasn't a lot of agriculture. There is some, but all those activities are going to pull on the amount of water that's available for recharge of the river from the groundwater. But it's also the water chemistry. We don't know, uh, we don't understand well what the historical quality of the water was going to Amistad. There's some indication that it was better then than it is now, maybe 1,000 TDS. Maybe some of the speakers here or some of the people online can fill in. But now we know it's about 2,000 milligrams per liter TDS. So it's decreased. So then that is going to impact the quality of the water in Amistad. Uh, you know, is it bad? Well, yes. It's anytime you're increasing the salinity of a freshwater source, it's got to be a concern. So I don't know if that answered the question that was posed, but it's some comments.
Yeah, and Ron, I know that you and others have been studying all the springs and the fingerprinting. Mauricio shows some of the fingerprinting, which in this case is the water quality. Um, it is super. I mean, we just see the water coming out, but you're really identifying where it comes. Mauricio, we have one question. Did you also sample for boron isotopes and also the complete set of halogens for this geochemical analysis? And I think this is coming from Randy.
Yes, sure. So I can actually I'll share my screen and show a figure I didn't include in the presentation. We did sample for boron 11 isotopes a while back. We didn't go too deep. We didn't go too deep into further investigating it at this. We haven't yet done that. But for example, here's one plot that we did that involved boron 11, and the main thing is just the main thing that we kind of arrived at just for that preliminary first project was just that there's clear differences in the relationship. For example, when you're looking at the boron 11 versus the inverse of boron, which is one of the different types of plots that people will often do for boron isotopes, is that Goodenough spring is kind of all out on its own, and then you have most of the Mexican wells and most of the wells, most of the Texas wells, kind of in different clusters, although there's some overlap. But overall, it's we don't have much to say about it at this point, but we have tested for boron 11, and then for the halogens, we have not done halogens yet.
I'm just in the middle of everything. So here, a question for any one of the speakers who wants to talk. So for any one of the speakers, in the irrigation zones, have so is there any reuse of the irrigation water, drainage water that comes out of the agricultural drains? So do you know if there is any recycled water reuse of the drainage water? Or has it been counted?
I think historically that it was from Bitter Waters. On reading that, they did talk about some of the historical efforts of indigenous people, and some of the early settlers would use canal systems off the river, and so there was some recycling or reuse of the water, but I think that's mostly in the upper reaches outside of where we were.
I'm just having here in between two things. One, this this really all these presentations really what it comes is the importance of the tributaries and paying attention to a lot of those. Like, I mean, typically the one that receives the most attention is the Rio Conchos and now the San Juan, but there is a lot of things in between. Um, hey, Ron, one. Okay, so I think at some point it will be super cool to share with you the data that Ramon has. So basically, it's daily data
Yes.
1900s to 2010. My friend, that was a lot of pain and suffer. So that one, it will be interesting to compare these reaches, gains, and Ramon and I, we spend more time than we should say on this, like state by state. Anyway, Raul, do you have a comment, question? Dale, Raul.
Hola,
Just one thing. Oh, I'm sorry.
buenas
Go ahead.
tardes. Sí,
Hi,
para
good afternoon.
complementar la
Yes, I
pregunta
would like to
que había hecho
compliment the question that
relacionada
I
con el
made
agua de retorno agrícola.
regarding the
No
agricultural reuse
sé
water.
si la terminología
So I don't know if the
en inglés sea la
terminology
misma, pero
in English is the
aquella
same one that we
agua
use in
que
Spanish,
no usa la
but that
planta,
water
que no se
not
infiltra
used
a
by
los
the plant,
acuíferos
that do not
y que no
get
se
into the
evapora,
aquifers and that
se
do not
mueve a
evaporate,
través de unas
moves
estructuras agrícolas que
through
son
agricultural structures
drenes agrícolas, no canales por los que se mueve
that
agua
are
dulce
not
del río.
channels,
No, drenes agrícolas
are
que están
agricultural
llevando
drains
el agua que
that
no
are
se utilizó.
bringing water that
En
has not been
México,
used by plants.
esa agua
In
no se
Mexico, that
contabiliza
water,
y no
it is
se
not counted
reutiliza.
and it
Mi
is not
duda
reused
era,
either.
en
So
Estados
my doubt
Unidos,
was the
en
following.
las
In the
zonas
United
agrícolas
States, in the
cercanas al río
like
Pecos,
agricultural
sí se
areas
contabilizan
closer to
estas
the Pecos
aguas
River,
y sí se
those water
reutilizan porque
are
son una fuente
measurable and counted, and are
importante
they reused because those
para
are an
dejar de
important
usar
source
agua de primer
to
uso.
stop
Esa
using
es
first
mi pregunta.
usage water? This was my
Hey,
question.
Ron, Mauricio, Ramon, anything from there to add? ¿Algo para agregar
Anything
ahí
to
a la
add
pregunta de
regarding
Raúl? Yo creo que
our comrade's
lo que
question?
pasa,
Rosario, please.
perdón, Raúl, yo lo que he visto aquí, sobre todo es en el sistema del Pecos. O sea, lo que pasa es que es las puras estaciones hidrométricas.
Yeah,
Uno
sorry for
saca
that.
agua y regresa, pero ese
Raul,
es el balance
what
que
I
hay en medio.
have seen here,
A
especially
veces
talking
ellos,
about
claro,
the
sacan
Pecos
agua y se
system,
la regresan
but the
abajo
thing is that the
de la
hydrometrical
estación.
stations, like you take water and then it goes back, but the balance is
No
made
sé qué
in the
tiempo
middle.
tengan. Yo veía que Raúl
Sometimes you
tenía
see
muchas
when they take
estaciones,
water
más
and
estaciones que
then
las de
it
nosotros.
comes down
No
to the
sé qué tanto se
station.
contabiliza.
So
Muchas de nosotros ahí con Ramón no las contabilizamos.
I'm not sure. I saw that Ron showed more
de
stations.
lo que yo sé, no
I
he
don't
visto
know if
mucho
they
ese
are
tipo de
counted or not.
retorno
Many
agrícola, al
of
menos
them are not
en la parte
counted.
superior del Pecos, de la
Yeah,
parte superior de donde
I think I
nosotros nos
can respond
enfocamos
to that.
en
As
el
far as I
forgotten
know, I
reach,
have
en el
not
segmento
seen
olvidado,
this
como
agricultural
por
return,
ejemplo,
at least when it comes
ahí
to
es
the
más principalmente, últimamente, más
upper
como
part where we
cosas
focus on
del
in the forgotten
petróleo,
region,
del gas, etcétera, oil and gas y todo
for
eso.
example.
Hay menos
So in
agricultura que
that
antes,
part is like
pero lo
more
que sí puedo comentar es
is like
que
related to oil, to
la
gas,
salinidad ahí
etc.
es muy interesante
and all
porque
that.
allá en
There's
los
less
lugares más
agricultural activity
superiores
than before,
de esa
but
parte
what I
del
can
Pecos,
see, what I
de la
can
región
say
que nosotros
is
nos
that the
enfocamos,
salinity is very interesting
la conductividad específica del agua del
because in
río
the
llegó hasta niveles de
most upper
39 mil
places in the region of
microsiemens
Pecos
por
River,
centímetro. Entonces muy
the
altas ya,
conductivity, specific
mientras,
conductivity of
y
the
es
river, or
más o
the
menos se
water,
mantiene en
river
esa parte
water,
del río como
reach
24 mil, entre los 20 y 30 mil.
certain
Hay
levels of
unos lugarcitos
microsiemens
con
per
solo 13
centimeter, so
mil,
very
etcétera.
high, to be honest. And more or less, this remains stable in that part of the river between 20 and 30,000, and there are some places that only have like 13,000 or so. So yes, I would say that there are salinity problems. In certain places, you can even see that there's a lot of salt in the rivers. It looks like snow, to be honest. So as Christine said, he has helped us a lot in that part of Pecos. So there's not a lot of agricultural use in that part of Pecos, and at least on the part that we focus on. And Christy also is also mentioning that very soon we will see, how to say, different produce water. I don't know how to call it in Spanish, but the water that is used for different oil and gas related operations. So this is happening. There are at least 5 permits, Christy, if I'm not mistaken. And there may be available in the following years. That's another reason why it's so important to get this data before all this happens. The idea is to be able to compare data. Regarding your question, I don't think there's a lot of return of irrigation in that part. But yeah, the salinity is a very important problem. Levels like 39,000 or something, thanks to the streams in the lower part, it lowers down to 2,000 or so, but it's very dramatic. Like salinity is an issue. When I went there in February, I didn't think the value was going to be so high. And I was surprised. I mean, prawns used to be there. I remember Mr. Arias, he told us about it. But yes, that's what I can say so far. Thank you. Thank you so much. So this salinity is something like that is a feature of underwater, not in that region. Not in that region. So, for example, I would say that Saumur, like, where does it come from? Where does salinity come from? Because it doesn't come from the superficial water, right? It must come from, likelihood from the under from the subsoil, the aquifers, right? Yeah, especially in New Mexico, they have investigated a lot the sources of salinity, and there are a lot of theories, there are a lot of research that think that it's due to the subsoil, due to the different geological layers that were formed, due to the fact that there was sea in that place before, so that contributed to the salinity as well. So definitely an important part of that comes from the subsoil. But what is interesting is that many of the wells that we showed, in general, these wells, many of them were from belong to one aquifer. In the upper part, they rely a lot on the Sentinel Pecos alluvium. It's not that deep as the Edwards in that part. And yes, this type of wells didn't have these levels of salinity. One of them registered like 13,000. There was a school that had a level of salinity of 13,000, but generally speaking, they have a conductivity of between 1,000 and 5,000 generally. So yeah, most of this salinity comes from northern places of the river. For example, there is the Salt Creeker, for example, which is a stream, and it's always part of the conversations when people talk about salinity-related problems. So yeah, the subsoil, I'm sure that it plays an important role. Thank you very much, Mauricio. Thank you. Yeah, you
esta
know
zona
what,
del
Raúl,
Big
in
Ben
this
estuvo
area,
bajo,
you
o
can
sea,
see it
millones
on
de
my
años,
picture.
estuvo bajo
This
el
is the
mar.
Big Ben.
O
Sí,
sea, si tú
And
vas a la zona del Big Ben,
this
cerca
area
entre
of the Big
Chihuahua
Ben,
y
like
Texas,
for millions of
esto
years,
estuvo
was
bajo el mar.
underwater. If you go to
Y
the Big Ben
la
area
cuenca del
between
río
Chihuahua and
Conchos, el
Texas,
río Conchos, se llama río Conchos
this
porque
was
encontraron
under
las
the sea.
conchitas. Y
And
la
the
gente
Concho
que vivía,
River Basin is
los
called like that
originarios,
because they found
eran
some
el pueblo de
shells,
los Conchos,
and
el
Concho
pueblo de
is
las
shell.
conchitas.
So
No,
the
nunca
people that
supimos
used
cómo
to
era
live there was the shells
el
people,
nombre original de, de
little
los pueblos
shells
originarios, no
people. We
sabemos. O
never
sea, como nosotros
know.
mexicas
We never
o
knew what was
aztecas
the
o
original
toltecas.
name of the
Nomás que
traditional
ellos se
peoples, like
autodenominaban
us,
el pueblo
Mexicas
de
or
las conchas.
whatever.
Y por eso el
But
río
we
Concho
know
se
that
llama
they
así.
were called
Pero
themselves the
ese estuvo bajo
people
el mar
of
también.
the
O sea,
shells.
todo
That's
esto que ves
why
aquí
the
estuvo
river is
bajo el
called
mar.
like that.
So
But
does
yeah,
it seem like
it used to
Chihuahua,
be under the sea,
básicamente,
and
toda la
all that you
vegetación
can
que
see here
ocupa?
was also under the sea.
sí, la
Yes,
planicie
all this
costera
Chihuahua
del
desert,
Golfo
basically,
es una provincia
all this
geológica
landscape.
que abarca
Yes,
hasta allá y
and
todos
also the coastal plain of the Gulf.
son sedimentos marinos
All those
y
sediments
por
are
eso
marine
hay una
sediments, and
altísima
that is why
salinidad. Eso
there is a
ocurre del lado de
high
Tamaulipas y
level
del
of
lado de
salinity.
Texas.
This happens on the Texas side and on
Y
the other
esa es la
side as
razón,
well.
como bien dice
So
Samuel.
that's the reason
Gracias.
why, as Samuel pointed out. Thank
Anyway,
you.
we got carried away, sorry, but there was a very vivid discussion about salinity here. Um, I don't know, I'm taking a look at the time,
Yeah.
and I really want to give Ron, Mauricio, and Ramon comments, questions. Ron Pinky swear we'll talk about the data, but before besides that,
Yeah, I just want to make a sort of a comment and a bit of an observation, but we've had an opportunity to work on the Devils, uh, and the Devils is a very different system. It's recognized as the last real pristine river in Texas. It doesn't have a lot of threat from oil and gas. It's not in the oil patch. There isn't a lot of agriculture. There isn't a lot of development. There's a lot of conservation easements along it to protect it. So it's staying fairly safe. There are always some issues. The Pecos is very different. It goes a long way. It has a very storied history of different impacts on it. And back about 10 years ago, when we were starting a lot of this work, I had an opportunity to speak with Roberto Salmon, who was the commissioner of SELA at the time. And I suggested that he do a similar study of what we're doing in Pecos over in Rio Conchos. And he said the mere suggestion of doing such a project up there made him break out in a rash because it's such a political hot potato of doing that up there that it, it just makes it extremely difficult. But at the end of the day, until you start getting those data, you're not going to understand that system either. And so I think it really needs some effort to understand that system and some of the others better along the way that the Pecos and some of the other systems are now being better understood.
Ron, totally agree. And we have exactly the same. I mean, and Randy Hanson has done a lot of work on the Pecos also.
Yeah.
But these gains and losses in the Pecos, in the Conchos, that's another headache as the one that you are seeing on the Pecos. Like my friend, plenty of white hair. Just
Yeah.
these two. Anyway, Mauricio, do you wanna comment?
No, I just think thank you for having us. But yeah, I just wanted to reiterate the importance of that a lot of this work, Ramon's work, Ron's work, the work that Ron presented and that I presented, has been possible largely due to the broad collaboration across different entities, NGOs, nonprofits, other research institutes, universities, etc. Wouldn't be the Pecos wouldn't be possible without the help from Friends of the Pecos, for example, Christy Muse from the Forgotten Reach, and Julie Louie in the Nature Conservancy in the Lower Pecos, and then a lot of the work in the Amistad area that I presented on wouldn't be possible without support from SELA, IBWC, the different Mexican and U.S. landowners, etc. So just broadly, having integrating all these different efforts across the board has been mainly possible because of all that, all those fostering of good relationships. So yeah, that's all that I have. Thank you for having us.
Ramon?
Yeah, thank you everyone for all these thoughtful and challenging questions, and for Mauricio's and Ron presentation. They reflect exactly why all this work we're doing matters. And I think it's just not like talking about case studies, it's talking about warnings and the real consequences that uh, we're facing, and the consequence for farmers, ecosystem, the cities, and two nations that we share we share the water on a stress river system. And yeah, we do science to make things better. And yeah, thank you so much for having me. And it was great to hear from your research, Mauricio and Ron.
And yeah, thanks, Ramon. As people say, like a long time listener, first time caller. I've seen you many, many times in these
Yeah, I'm a fan.
conversations. Yeah, I know. And I don't know. I mean, you know that the permanent forum is yours. If you want to organize or want to share ideas with us of other topics, for me, this it really looks like we need to do groundwater, surface water, springs interaction along the river. I'm just seeing the discussion that Randy and Kevin or Banchix are having on the chat, and the importance of groundwater and springs. I like right now every drops water, every drops matter. So thanks for joining. Rosario, any last word?
Yes. Yeah, I just want to drop a usual bomb so we can all go and run. Um, Based on what we discussed today. So, if we have overestimated flows potentially, and if the recharge area or the source of water that we thought was coming from one side actually comes from the other side, it says something for the treaty. For me, it says that the system is alive. We're never going to get it right, not 100%. But the fact, the question would be, what kind of instrument then, or what kind of alternatives do we have to adapt our current legal framework to these live systems that we don't know much about? And I understand that back in the days we needed to have something, right? Some numbers. But does really fixed numbers work uh, under current conditions? Do we need to rethink about how do we share equitable and reasonable use across the two countries based on, discovering and discovering and discovering? So for me, it doesn't make sense to have fixed numbers. We need to think a more mature way to represent the systems and share it equitable and sustainable for the future. That's my bomb, and I'm gonna run. Thank you everyone for joining us as always. We love to have this conversation. I learned so much. You have no idea how much
Yeah,
I've learned. So thank you.
yeah, Rosario, please, this forum is yours. If you want to propose a topic, an event, if you want to partner with us or something, do let us know. This is your forum. Muchas gracias a todos. Qué
Thank
bueno
you,
que estuvieron
everyone.
por aquí.
Thank
Nos
you.
vemos. Chao, chao.
Thank you. Gracias.
Gracias.